Okay, so let's start. Hi everyone. So let us start today's session. And uh, this is actually the Tuesday session batch for the doubt clearing session. But since I'm unavailable next week, I am preponed it to today, Friday. And so, okay, anyway, so let us begin. We will discuss some problems from the week 5 assignment today, which will help you uh, learn the concept better or help you with the exams and assignments also. Okay. So let us take the first question. So in this tutorial, we are mostly focusing on the number system. So here, first question is the hexadecimal representation of 7214 base 8 and 3645 base 8 are dash and dash. So first of all, we need to know what is the binary conversion of base 8 system, right? So for that, what we will do is, let me add a page. Yeah. So we have uh, 7214 base 8, that is equals to, you'll write it in the binary form. 4 is 0 0 1, 1 is 1 0 0, 2 is 0 1 0, and 7 is 1 1 1. Okay, just so this is the binary conversion of 7214. Similarly, other number is 3645. 3645 in octal, we can write it in binary as 1 0 1. That is okay. 4 is 0 0 1, 6 is 1 1 0, and 3 is 0 1 1. Okay, so how do you convert octal to binary? So let me reiterate. So every octal to binary. So let's say you have 1 2 3 4. For every corresponding digit, you just write 3-bit binary form. An octal is what? It has digits from 0 to 7, right? Total 8 digits. So in 3-bit, we can represent everything from 000 to 111, that is 0 to 7. Okay. Now we have to convert it to hexadecimal. Hexadecimal is 0 to 15. That is 00000 to 1111. 0 to 15. So it has 4 bits. So to convert octal to hexadecimal, just form groups of 4 bits. Right. So what we had here, so now we'll form groups of 4. So one is this, second one is this, and third one is this. Similarly here. Okay. So what is this? This is 8, 12. This is 8. This is what? 8, 4, and 2, 14. And this is what? 5, 8, 9, 10, and this is 7. Okay. So now in hexadecimal system, we have 0, 0, 0, 0 to 1, 1, 1, 1. So then from 0 to 9 we can represent easily, right? 1, 0, 0, 1, 9. But how do we represent 10? We represent 10 as A, B, C, D, E is 10, 11, 12, 13, 14, 15 is F. 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0. Okay. So what this actually is, then 12 is C. 8 remains 8 and 14 is E. Similarly 10 is A. So answer is 7214. 8 is base 8 is 14 base 16 E8C, and 3645 base 8 is 7A5. Um, is this question clear to all, or do you want me to repeat any part of it? Please let me know. You can type in chat, or you can also unmute yourself and talk. Okay. Thanks, Lavkush. Let's move on to the next question then. Okay. So the next question says, in the range of values in decimal that can be represented by fixed 16, 8 point representation is. So what is fixed 16, 8 point representation? That means we have total 16 bits. Out of those, 8 bits are decimal. Okay. So that, what does that mean? We have number, let's say 0, 0, 0, 0, 0, 0, 0. 8 bits are here, then 8 bits are here. So these are total 16 bits. And we have 8 bits in decimal and 8 bits here after decimal. So it's all is base 2. Anyways. So now in this number system, so let me. So in this number system, the minimum number that you can represent is this only, right? All zeros. That is corresponds to 0. The maximum number that you can represent is all ones, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, base 2. So now if you see what is it? So these are all powers of 2, right? 2 to the power 0, 2 to the power 1, 2 square, 2 cube, 2, 4. This is actually what? 0, 2, 4, 8, 16, 32, 64, 128. So if you add all these together, what you will get is 255. This is, sorry, 1, not 0. So this part corresponds to 255. This similarly we have 1 by 2 to the power 0, sorry, 2 to the power 0, 1 by 2 to the power 1 by 2 to, or you can write it as 2 to the power minus 1, 2 to the power minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. So if you calculate this, let me just find what is 2 to the power minus 8. Okay, so then we calculate it in my calculator. So we will at least know what are the number of digits after decimal. To the power minus 8. So 2 to the power minus 8 is 0.00390625. Okay. Okay. How many digits are there? 1, 2, 3, 4, 5, 6, 7, 8. So in 1, 2, 3, 4, 5, 6, 7, 8. So only this one we have 8 digits after decimal. Right. So answer is this actually. Anyways, you can just find it out. It just means 0.5 and this means I think 0.25, 0.125, 0.0625 and so on. If you just add all those, you will get this number. Okay. So that is why the minimum that we can represent is 0 and the maximum that we can represent is 255 point this whole thing. Okay. So that is the range that has been asked in the question. Okay, so if there are any doubts, please let me know. Else we will move on to the next question. Okay, since I don't see any questions, I'll move on to the next one. If you do have, please stop me any time you want. Okay, this is a very interesting question. So they say that we have this equation where some number in octal form is equal to some other number in hexadecimal form, right? We have to find the values of P and Q. So how do we do it? Let me rewrite it. We have 5P 364 base 8 equals to 5AFQ base 16. Okay, so I'll write it. What does that mean? Sorry, this is what 8 to the power 0. If I expand this, it will be 4 into 8 to the power 0 plus 4, sorry, 6 into 8 plus 3 into 8 square plus P into 8 cube plus 5 into 8 to the power 4, right? And this thing is 5 into 16 cube plus A is actually 10, right? 10 into 16 square plus F is 15, 15 into 8 plus Q into, okay, 16 plus Q. Okay, fine. So if I rewrite this part again, both are equal. So if I write it as 4 plus, okay, so I can write it as 6 into 8 plus 3 into 8 into 8 plus P into 8 into 8 into 8. Write it more clearly. 5 into 8 into 8, 8 plus P into plus 3 into 8 into 8 plus 6 into 8 plus 4 equals to 5 into 16 into 16 into 16 plus 10 into 16 into 16 plus 15 into 16 plus q. Okay, so now how can I compare both two is if I convert both of them to the same number of 16s or 8s. So I'll convert all the 8s to 16. So how do I do that? So okay, so this is actually what 2 into 4 into uh, 2 into 4, right? Or I can, yeah, each 8 is 2 into 4. This is also 2 into 4. So how I can rewrite 3 into 8 is say 2 into 2 into 4 into 4. It is, sorry, 3 into also. So 3 into 4 into 16, 12 into 16. So I'll rewrite it as 12 into 16. Similarly, we have p into 8 into 8 into 8. We can rewrite it as 2 into 4, 2 into 4 and 2 into 4. So just a minute. Yeah, so I have p 2 into 2 into 2 into 4 into 4 into 4. So that is we can have with these two together 2p. This is 4, 4 4 the 16 into 16 into 16 into 16. So I can rewrite it as, sorry, only two 16s. This is 2p into 16 into 16. We also have this term 5 into 8 into 8, 8 into 8. Each is 2 into 4, so we have 5 into 2 into 2 into 2 into 2, 4, 4, 4, 4, 16, 16, another 16, 5 into 16 cube. So I'll rewrite this as 5 into 16 cube. Now, okay, I can write this as 3 into 16, 4 remains as it is. Okay. Okay. So what we have now from this side, we have 5 into 16 cube plus 2p into 16 square plus 12 into 16 plus 3 into 16 plus 4. And on RHS we have what actually 5 into 16 cube plus a into 16 square plus f into 16 plus q. So I can combine these two as 15 into 16, that is f into 16. So this side we have 5 into 16 cube plus 2p into 16 square plus f into 16 plus 4. And this side we have 5 into 16 cube plus a into 16 square plus f into 16 plus q. So if we compare both the sides, we can compare like this part and this part is same, and this part and this part is same. So we will take this part and this part is also same. This is equal to this, and Take another. This is equal to this. So we have 4 equals to Q, and 2P into 16 square equals to A into 16 square. 2P equals to A equals to 10. That means P equals to 5. So that is why we have P equals to 5, Q equals to 4. So I'll repeat once more what we did. First, we expanded M, then converted all the 8s to 16s so that we can compare LHS and RHS. Then we found what, then we could easily compare the uh, coefficients of these powers. Right? That is how we found P is 5 and Q is 4. So is there any doubt? Okay. So I'll move on to the next question then. So this is a very similar question. So I'll leave it on to you to solve it, or we can solve it at the last if we have time. So let's skip it for now. It is just same as before. So we can solve it at the last. Okay. So let us take the next question. Okay. So we have given 2's complement sign representation of P as this and find the P by 4 in 1's complement form. Okay. So this is 2's complement of some number P. So we have 1, 1, 1, 1, 0, 1, 0, 0. So if this is in 2's complement form, how do we convert it back to normal form? We take its 2's complement again. And a shortcut to take 2's complement is start from right. If you encounter 0, just write it as it is 0, 0, 1. As soon as you encounter a first one, invert all the digits towards your left side. 1, 0, 0, 0, 0. So this is the 2's complement of this. So I'll repeat, how do we write 2's complement of any number? Let's say we have 0, 1, 0, 1, 0, 1, 0, 1, 0. So we start from this side. If we see a 0, write it as it is. If we see a 1, write it as it is. As soon as we see the first one, is the first one, write it as it is and invert all digits on left of first one. So we have 1, 0, 1, 0, 1, 0, 1. This is the 2's complement. A shortcut uh, to find a 2's complement. Love Kush is saying sir problem session का PDF मिलेगा. Yes, I will share the PDF in the drive link which you can find in the Google Sheet. I'll share the sheet link here also. So this is the link of the sheet where you can find the link for the PDF. So there is the drive link and alongside my name in week 5, I will I will add the drive link for the PDF and the YouTube link also of this recording. Okay, so this is how we find 2's complement. So anyway, so the given number is this and its 2's complement is this, and this is what? This is corresponds to 10, right? Sorry, not 10, I think 12. This 8 plus 4 is 12. So now the question is find P by 4, that is 12 by 4. That is what? 3. Okay, so 3 in binary is, we found P equals to 12, P by 4 equals to 12 by 4 equals to 3 in base 10. Now 3 in base 2, sorry, 3 base 10 equals to what in base 2? That is 0, 0, 0, 0, 0, 0, 1, 1, right? This is 3. Now we have to find its ones complement. Why do we find one complement? Because it is asking find P by 4 in ones complement form. That's why we are finding it. Ones complement is simply invert all the digits 0, 0, 1, 1, 1, 1, 1, 1. This is the answer. So C is the answer. So is this clear? So the only thing you need to remember is how to find the 2's complement quickly. For that I told you, start from right side here. As soon as you start from here, see if there's 0, write it as it is. If there's 1, write it as it is. But after that, invert all the digits. After you see the first one, invert all the digits. That's how you find 2's complement very quickly. This would be helpful for you in your exams and later on. So please remember this. Okay, so let's see the next question. A is this and B is this are two 8-bit signed 2's complement representation number. The signed 2 cosmetic number of A cross B is okay. So we have if signed 8-bit signed 2's com representation. That means the our 8th bit is sign bit. So if MSB equals to 1, that means negative number. MSB equals to 0, that is positive number. So in this representation, we always write negative numbers in 2's comp form and positive numbers in normal form. So what we have is 1, 1, 1, 1, 1, 1, 0, 1. So this is negative, right? That means it is in 2's complement form. So what does it represent? We'll take its 2's complement. So we see the first one here itself, 1. So we invert all the digits later. 1. Sorry. 0, 0, 0, 0, 0, 0. So it is minus 3, right? This means 3, but we know it's a negative number. So this is minus 3. A is minus 3. And B is 0, 0, 0, 0, 1, 0, 1, 0. This is positive, so it is already in normal form. No need to take its 2's complement. So this is what? This represents 0, 1, 0, 1 means 10. Okay. So A equal to minus 3 and B equals to 10. So A into B is what? Minus 30. So, okay. So how do we represent, since it is answer is negative, it will answer will be in 2's complement form. So first let us write just binary number representation of 30. That is okay 0, 16 plus 8 plus 4, not like this. 16 0 0 0 0. Okay, so this is 30. I think so. It is 30. Extra zeros here. Yeah, this is 30 and minus 30. If we take its 2's complement, 2's complement, it is 0, 1. Invert all next numbers 1, 1, 1. Okay, this is minus 30. So this should be the answer. 1, 1, 1, 0, 0, 0, 1, 0. 1, 1, 1, 0, 0, 0, 1, 0. I'll repeat what we did. We see both the numbers. If the first digit is 1, then it's a negative number, and negative numbers are always in 2's complement form. And positive numbers are already in normal form. So it is 0, so it is already in normal form. So we found what was the negative number. Negative number was minus 3. Positive number was 10. Minus 3 into 10 is, we know, minus 30. So since it is negative, we have to represent it in 2's complement form. And we found that. Okay. Fairly simple. Okay. And if you want, you could do direct multiplication also, but that is very cumbersome. So we know this, right? We have A is 1 1 1 1 1 1 0 1 and B is 0 0 0 0 1 0 1 0. So we if we do A cross B, then 1 1 1 1 1 1 0 1 cross 0 1 0 1 0 0 0 0 0 0 0 0 cross 1 0 1 1 1 1 0 1 1 1 1 1 1 0 0 0 0 0 0 1 0 1 1 1 1 0 1 0 0 0 1 1 1. Okay, so we take the 8 digits and ignore rest. 3, 4, 5, 6, 7, 8. And their overflow, that means it's a negative number. So we take the 8 digits and it's correspond to 2's complement of 4 of minus 30. So you can do it in this way also, but this is fairly easier. Okay. Any doubts here? Okay, if not, let's move ahead. So the question is, a 1-bit full adder circuit takes 70 nanoseconds to produce the sum and 50 nanoseconds produce the sum and 50 nanoseconds to produce the carry. If a 6-bit parallel adder is to be designed with full adder block, what will be the minimum total delay in the getting the result? Okay, so we see that delay sum is more than delay carry, right? So how does full adder work? We have A, B, and carry. Then we get sum and next carry, right? So okay, that's good, but uh, okay. So if producing S0 gets 70 nanoseconds, producing C1 gets 50 nanoseconds, and we have another uh, block ahead of it, right? Say we have A2 and B, A1, A0, B0 are coming, and here A1, B1, and this carry C0 output as S0 and C1. This S1 and this C0, C1 goes here. Then only this sum will give me, will take another 70 nanoseconds. And after, so 70 nanoseconds, we'll get this sum. If we have AB, A1, B1, and C1, and then after 15 nanoseconds, we get a C2. Okay, so anyway, we see that to produce sum, only 17 nanoseconds are required. But this carry actually propagates, right? It requires only 15 nanoseconds, but this C1 only goes to here. That that is counted in the sum, right? What is sum? A XOR B XOR C, right? But you cannot do XOR C until you have C. So for getting C, there is a 15 nanosecond delay. So every C will get propagated. So C1 to C2 to C3. So you will get for 4 bit C0 will not get propagated, but for 4 bits you will have 3 into 15 nanosecond delay from carry. Only 70 nanoseconds for some. So in general, you will have 70 nanosecond plus n minus 1 the number of adders, 50 nanoseconds. That is, so here we have 70 and plus 4 minus 1 into 50. We have okay, we have 6. Okay, sorry, n is 6 here. N is 6. So n minus 1 is 5. 70 plus 5 into 50. That is what it is. 320 nanoseconds. So total delay is 320 nanoseconds. And now how many 6-bit additions per second can be expected from this design? So to find that number of frequency, that means frequency is being asked. Frequency is equal to 1 by delay. It is 1 by 320 into 10 to the power minus 9. So that is 3.125 into 10 to the power 6 additions. So answer is this. Is there any doubt here? If yes, please let me know. I'll repeat it. Okay, let us move on to the next question. So we have this, suppose following is true, 400 radix x is 256, 1000 f 500, find the relation between x and y. Okay, fine. So first we'll take one part, then we'll take the other part. So we have 400 base x equals to 256, right? So we have 0 into x to power 0 plus 0 into x square 1 plus 4 into x square equals to 256. That means 4x square equals to 256. X square equals to 256 by 4, which is actually what? 6 to 4. X square equals to 64. X equals to 8. So we know x equals to 8. And similarly, we will do for y. 100y equals to 256. 100 base y, sorry. So 1 into y square plus 1 into y plus, sorry, 0 into y to power 1 plus 0 into y to power 0 equals to 256. Y square equals to 256, so y equals to under root 256, that is y equals to 16. So we can see x is less than y. B is the answer. Yeah, to read you are right. Option B is the answer. This is fairly simple. You just find the equation for both of these terms and then just you can find the radix easily. Okay. So let us move on to the next question then. Yeah. Please read this once. Which of the following are true? In fixed point representation, width and position of binary point are not defined. Fixed point arithmetic is similar to integer arithmetic. Sorry. Okay. Floating point representation has fixed precision. And floating point representation comprises of two parts, matrica and exponent. In floating point representation, gap between numbers is higher for larger numbers. So, so this is false. Both width and position are defined. This is correct. And has fixed precision. This is also wrong. So floating point means you can have any number of uh, any number of digits after decimal. That's why it is floating, that not fixed. That means the precision can, can vary depending on the number of digits after the decimal. So this is false. This is correct, and this is also correct. Okay. So the answer is 1, 2, 4, 4, 5. So 1 is incorrect, 2, 4, and 5 are correct only. So C is the answer. So this is fairly theoretical, and you can see it in the lectures also. Let's rest on this. Yeah. So let us move on to the next part. In the following circuit diagram, what are the values of M and N respectively? So let's start this one. Okay. So we have A in this, B in this. So fine. So in a half adder, we know half adder A and B, and if sum and carry, sum is actually A XOR B and carry is A dot B. Okay. So here what we have is we have a half adder A B. We have another half adder. And we have M N as output. We have sum and carry S1 C1. They are going like this. So what it means is, so S1 is what? A XOR B. C1 is A dot B. Now M is what? M, if M is the sum, M is S1 XOR C1, and N is S1 dot C1. So if I expand this, M is S1 XOR C1, right? So S1 is what? A XOR B XOR AB, right? So okay, so we can write it as this part as A bar B plus A B bar XOR AB. That is A bar B. Okay, that is A bar B plus A B bar dot AB whole bar plus A bar B plus A B bar whole bar dot AB. Right. If this is X, this is Y, X Y bar plus Y X bar. Is this? Okay. So if we expand this, A bar B, A bar AB whole bar plus AB bar AB whole bar, or okay, let's not do this. We can do this. A bar B plus AB bar A bar plus B bar by applying De Morgan's here, plus A bar B whole bar dot A B bar whole bar dot A B. So this is what, if I multiply each term, if you multiply this and this, that is only A bar B plus multiply this and this, that is 0. If we multiply this and this, that is 0. And if we multiply this and this, that is AB bar. Okay. Plus, if we can expand this also, A plus B bar, A bar plus B dot AB. Okay, so we have A bar B plus AB bar plus A bar is 0, AB plus A bar B bar dot AB. So we have A bar B plus AB bar plus AB. Okay. Take common equals to A bar B plus, if we take this, okay, B common, A plus A bar plus A B bar, B plus A B bar, B plus B bar A equals to B plus A. So our M is B plus A. Okay. And C1 was, oh sorry, N was S1 dot C1, that is A XOR B dot AB. A bar B plus A B bar dot AB. This is 0. Okay. Why? Because this A bar and A will cancel, this B bar and B will cancel. So N is 0. So we have M is A plus B and N is 0. So I'll mention this, what I have done here. XOR here, we just multiplied this. This is just XOR. Here is De Morgan's here and De Morgan's here. Then I've just multiplied here, and this is again De Morgan's. Then again I just multiplied it and got this. Then I took B common, A plus A bar is 1. Then B plus B bar is B plus A. This is one of the identities. A plus A bar B equals to A plus B, or X plus X bar Y equals to X plus Y. That's why M is this and N is 0. So D is the answer. So this is purely uh, Boolean algebra. So if there is any doubt, please let me know. If we shall continue. Okay. So I just have a few more questions. So, okay. So this is simple binary um, addition subtraction question. So let me see 1 second. Okay, so let us do a few of them, not all. Okay. So we have first is A part is add 9 to 16. That is fairly easy. So 9 is what? 1 0. We use 8 bits. Okay, and sign system. Okay, so 9 is plus 9 is 0 0 0 0 1 0 0 1 plus 6 is 0 0 0 0 0 1 1 0. Add them, we get 1 1 1 1 0 0 0 0. That is the answer, and it is actually what? It is 15. Okay, this is A part. B part is add plus 14 plus minus 17. Okay, so 14 and negative number, that means we write 2's complement. So 14 is what? 0 0 0 0 1 1 1 0 plus 17 we write as 0 0 0 0 0 0 0 1, sorry, 1 0 0 0 1, and minus 17 we take its 2's complement. So that is 1 1 1 1 0 1 1 1. So plus 14 plus minus 17, that is 0 0 1 1 1 0 plus this part 1 1 1 0 1 1 1 1. Add it. 0 plus 1 is 0. Sorry, 0 plus 1 is 1. 1 plus 1 is 0. Carry 1. 1 1 1 1. Carry 1. 1 carry 1 1 1 1 1. So this is the answer, and since it is 1 here, it is negative number. So its 2's complement we take, that is 1 1 0 0 0 5 6 7. Okay, that is 3. So we know it is negative. So answer is minus 3. And we already know, right? Minus 17, 14 is minus 3. And we are getting that also. This is how we do it. So we take, let's take some more. This is easy. This is similar to this. Let's take last one. Both are negative. E is, go to E. So you have to subtract minus 17 from minus 32. So we have to do minus 17, sorry, minus 32 minus 17. Or we can write minus 32 plus 17, right? So what is 17 We can write in normal forms. It is positive. 17 is 0, 0, 0, 1, 0, 0, 0, 1 plus 32 we write as 0, 0, 1, 0, 0, 0, 0 and minus 32 we take its 2's complement. So for 2's complement we start with right side and keep writing zeros until we encounter a 1, write it as it is, then invert all the digits. So this is minus 32. And we have minus 32 plus 17. So minus 32, 1, 1, 1, 0, 0, 0, 0, 0 plus 17. 17 is 1, 0, 0, 0, 1, 0, 0, 0. Okay. What do we get? 1, 0, 0, 0, 1, 1, 1, 1. So it is a 1, it is negative. So if it's negative, we take a 2's complement. Negative 2's complement. So it's so 1, 1, 1, 1, 0, 0, 0, 1. Negative. So its 2's complement is 1, 1, 1, 1, 0, 0, 0, 0. This is what? 15. So answer minus 15. And we could solve it also. Minus 32 plus 17 is also minus 15. So this is clear, right? So wherever we have, so one only things that we note is negative numbers we write in 2's comp form. Positive numbers write in normal form. Okay, so this is the takeaway. Rest everything is simple. Is there any doubt here or in any of this arithmetic? Okay, I just have one more question for today. Okay, so the question is determine the possible bases or radices of the number which satisfy the following arithmetic operations. So it is a very interesting question. If you see, so how do we do it? I'll just tell you. Okay, so let us start with so we don't know what is the base, right? So we have this like 1, 2, 3, 4 base x, base x, base x. So since the base is x and we see two things. First is see the digits. Second, solve the equation. Okay. So if you see the digits, the max digit in part A, max digit is 6, right? So x must be greater than equal to 7 at least. And if we solve it, 1, 2, 3, 4, 5, 4, 3, 2. If we add it, we get 6, 6, 6, 6 as it is. So any number system with base greater than equal to 7 is the answer for this one. Okay. So what we are doing, we just see the number of digits. Sorry, what is the digit? The highest digit is 6. So that means if highest digit is 6, then x must be greater than equal to 7, right? So in binary, right, we have 0 and 1. Highest digit is 1, but radix is 2. Similarly, if the highest digit is 6, radix is greater than or equal to 7. Okay. Then we just solve this equation. That is, we just try to add it. And if we are getting the correct answer, that means, yeah, base is greater than or equal to 7. Let us do part B. 14 by 2 equals to 5. Okay. So what does this mean? So it is not, I can write 14 by 2 is 7 because we do not know the base. So it is like 14 base x divided by 2 base x equals to 5 base x. Right. So if I expand this equation, so one thing I see is radix, since max number is 5, radix it must be greater than or equal to 6. Now we verify by solving the equation. So this is 1 into x to the power 1 plus 4 into x to the power 0 divided by 2 into x to the power 0, 5 into x to the power 0. So this is what x plus 4 equals to 2 into 5 is 10. So x is equals to 6. Here we have found x is 6 only, not greater than 6, not less than 6, x is 6. Okay, so this is done. Part C is what? 33 by 3 is 11. So this is simple. So that means 33, how will we get this? 23 base x by 3 base x equals to 11 base x. So max digit equals to 3. So radix return equal to 4. And 3, if we expand it, we get 3x plus 3 divided by 3 equals to 1x plus 1. That means 3x plus 3 equals to 3x plus 3, which is always true. That means our answer is radix greater than equal to 4. Next part, 54 by 4 equals to 13. So we have 5x plus 4 divided by 4 equals to 1x plus 3. Okay, one more thing. Radix written equal to 6 because max digit is 5. Now it's verified with the equation. If 5x plus 4 equals to 4x plus 12, x equals to 8, right? So yeah, so by seeing the digits we found radix was greater than or equal to 6, and by solving the equation we found that it is exactly 8. So answer is 8. One more part. Uh, 24 plus 17 is 14. Part E is 24 plus 17 equals to 40. Base x, base x, base x. So 2x plus 4 plus 1x plus 7 plus 4x plus 0. Sorry, equals to 4x plus 0. So we have 3x plus 7 plus 4 is what? 11 equals to 4x. If we use 11 equals to x, so x is 11. That is clear from here. And the last part for today, the part is under root 41 is 5. Okay, good question. Under root 41 equals to 5. Okay, so we have, again we will write it as x, base as x. So 4 into x power 1 plus 1 into x to power 0 to 5 into x to the power 0, and this whole is power 1 by 2. 4x plus 1 by 2 is 5. So if I take square, 4x plus 1 equals to 25. 4x equals to 24. X equals to 24 by 4. X equals to 6. So radix is 6. Also, we see in larger digit is 5. So radix, if you could have said that radix was greater than equal to 6. And here we found that it is exactly 6. So this was the last question. So in these questions, we see two things. One is see the digits used. And if we see the digits, we can just find and approximate that what is the minimum, it tells minimum radix. Then what we do is solve the equation. And if equation always satisfies, then answer is what we get from here, that is something like x greater than equal to 7 or something. And if we have to solve the equation to find x, then we get x, whatever x it is. Okay, so that was all for today, and please let me know uh, if you have any doubt in this part also. You ready? Okay, okay, it's fine then. So since I've solved all the questions and there were no doubts, and the student only you came today. So if there are no doubts, let's end this session today, and we can continue from the next assignment in the next session. And those who might watch it on YouTube, as many have not joined, if you have any questions, please comment on the YouTube video, or yeah, that's it. Yeah. Thank you, Purity. Thank you for joining.